Welcome to this deep dive.
Oh, hey, thanks for having me.
Today we're diving into Douglas Hofstadter's Gödel, Escher, Bach, an eternal golden braid.
A classic.
Seriously, you gave us like a whole stack of stuff, not just bits of the book, but reviews and analyses too.
Yeah, I figured, why not get the full picture?
This is going to be a wild ride exploring like systems, self-reference, and even what intelligence is.
It's a pretty heady mix.
So right off the bat, Gödel, Escher, Bach. The title itself, it's like, whoa.
Yeah, three totally different guys. What's the connection, right?
A logician, an artist, and a composer. What could they possibly have in common?
That's the beauty of it. On the surface, it's baffling.
Uh-huh.
But Hofstadter, he's brilliant. He shows you those hidden links.
Okay, so spell it out for us.
All three, working in totally different fields, were wrestling with the same ideas.
Like what?
Self-reference and these systems within systems.
So like a hidden structure to creativity, no matter if it's numbers or images or sounds.
Exactly. Like there's this underlying code to how we create. And to show that, he uses some seriously mind-bending math.
Oh, boy.
Gödel's incompleteness theorem.
Yeah, I've heard of that.
It's one of the most profound ideas in logic, and Hofstadter makes it, well, maybe not easy.
Right.
But definitely captivating. Like a good story.
Okay, but before we get too deep, rewind for a second.
Sure.
For those of us who aren't like math geniuses, what even is a formal system?
You're right. Good point. That's key to understanding Gödel.
Uh-huh.
Think of it like a game, but with really strict rules.
Okay, I can get that.
Like chess. You got your pieces, how they move, and the goal is checkmate.
Checkmate, got it.
That's a formal system.
Okay.
Now, what Gödel's theorem says, even in a system that perfect, you can make totally legal moves.
Winning moves even.
Right, but you can never prove they're the best moves just using the rules of the game.
Whoa, so it's like there are limits to logic itself.
Exactly. Like there's truth out there, but our tools can't quite grasp it.
That's kind of freaky.
It is, and that's where these strange loops come in.
Strange loops.
Hofstadter connects Gödel to these loops, where systems like collapse in on themselves, like a hand drawing itself.
Ah, like Escher's drawing hands from
Bingo. Or his print gallery, where the viewer's part of the image they're looking at.
mind-bending stuff.
Visual strange loops. And then you have the classic paradox like, this statement is false.
Yeah, that one hurts my brain.
Right, it twists your logic in knots, just like a system trying to define its own truth.
So Hofstadter's saying these loops, they're everywhere.
Everywhere. Math, art, music, even how our brains try to understand themselves.
Which makes me think, AI. If our brains have these limits, could AI help us break through?
That's the question, isn't it?
Hofstadter uses those dialogues, right? Achilles and the tortoise.
All the dialogues are brilliant.
Yeah, to explore AI and all that.
One of them uses the MU puzzle. It's simple, but it shows how hard it is to pin down meaning in a system.
The MU puzzle. Ever tried it? You start with MI, and you got to get to MU using these specific rules.
Sounds easy enough.
It's deceptively simple. You get so lost in the rules, you forget what the symbols even mean.
So like a metaphor for our own minds. We're in the system we're trying to understand.
Right, back to those strange loops.
It's like that story about the crab who claims he built a machine to judge. Like, musical beauty. Hilarious story, but makes you wonder. Can we ever have a system to decide something that subjective?
That's the heart of it. The beauty decider is like searching for a system to decide truth in math, which Gödel already told us no can do.
So are we, like, trapped? Fundamental limits on what we can know, even with logic.
That's the million-dollar question. Hofstadter seems to suggest, yeah, formal systems, no matter how complex, they're inherently limited, especially when we try to model something as messy as the human mind.
He uses that jukebox analogy, right? Input, output, simple.
Precisely. But with minds, meaning isn't that simple. It's not just coded in some neural pattern.
Yeah. It comes from this web of associations, contexts, experiences.
More than just pressing a button and getting a song.
Much more implicit, much harder to grab hold of.
It's like trying to understand the whole history of music just by listening to one song.
Beautifully put. And that brings us to another key idea. Multiple levels of description. To get something complex, like the brain, or an ant colony.
Right. You can't just look at the individual pieces, the neurons or the ants. Yeah.
You got to see the patterns, the interactions on a higher level.
To grasp the whole picture.
Exactly. And that's where chunking comes in.
Chunking?
Both for AI and us. We group information to make it manageable.
Makes sense.
Like learning language, we don't memorize every sound individually. We learn words, then phrases building up.
Okay, so we chunk information. But if understanding a system means seeing it from the outside,
Uh-oh, here comes the paradox.
can we ever truly understand our own minds? We're stuck inside the very thing we're analyzing.
And that is where Hofstadter introduces subjunctive, or maybe you could call it counterfactual thinking.
Okay, I'm intrigued. Subjunctive thinking. How do we even get from our brains to that?
He uses this image to illustrate it. Imagine a football game, but played with a spherical ball.
A spherical football. Okay, my brain's hurting a little. What's the point?
It's about imagining other realities, you see. Worlds with different rules, where things could be different.
So, like, what-if scenarios? What if gravity went backwards, or time was like a thing you could touch?
Exactly. Hofstadter argues this ability to imagine other realities, it's key to understanding our own reality.
I'm not sure I follow.
By comparing what is to what could be, we see the structure shaping our thinking.
Like in Escher's work, he messes with perspective, creates those impossible spaces.
Precisely. And Hofstadter says our minds are always doing that internally, building little subjunctive worlds to make sense of things.
So more than just daydreaming, it's like fundamental to how intelligence works.
It's how we learn, how we solve problems, even form our sense of self.
Okay, but if that's so human, how does AI stand a chance? Aren't computers all about logic and rules, not what-ifs?
That's the catch. AI struggles with that. Formal systems, that's what most AI is based on, they're great at following the rules. But exploring those subjunctive worlds, that's a different story.
Because our thinking, it's always being nudged by those what-ifs, right? Possibilities a computer wouldn't even recognize.
Exactly. And that makes modeling human intelligence so difficult.
So can we ever have truly intelligent machines if we can't copy that?
That's the challenge. Hofstadter, he seems to be saying it's not just about faster processors, it's about the nature of meaning itself.
Okay.
How we represent the world, self-awareness, all that deep stuff.
So instead of copying a jukebox, we need AI that's more like a composer.
No, that's an analogy.
Something that makes its own music, so to speak.
And it brings us right back to Gödel, Escher, Bach. They were masters of systems, both rigorous and playful, showing us something deep about creativity and self-reference.
So to understand intelligence, we need that same approach. Playful, multi-layered.
Break out of the rigid systems, explore the loops that make us human.
The loops. That makes Gödel, Escher, Bach so mind-blowing. It's not just about the links between math, art, music.
It's about intelligence itself, how our minds create meaning from this crazy world.
You know, it's funny, when I hear about these formal systems, like the ones Hofstadter talks about, the MIU system,
The PQ system.
Yeah, that one. They seem so simple, but they get at such deep stuff.
That's Hofstadter for you, highlighting how even simple systems, they can reveal profound truths.
About logic, math, how we think.
But he also shows their limitations, that even the most powerful systems have boundaries.
Like that non-Euclidean TNT example, right?
Yeah.
Tweaking the rules of a system just a tiny bit, and boom, whole new universe.
Logically sound, but totally different. It's like saying there are multiple ways to build a universe, each with its own truth. No single right way to do math.
That makes math feel way less intimidating. Like less a set of eternal truths and more like a language.
With different dialects, all valid in their own way.
But then, that makes me think about meaning.
Yeah.
If there were all these systems, how do we even know what anything means?
That's where it gets really deep.
Uh-oh.
Hofstadter argues meaning isn't in the symbol itself, but in the system it's part of.
So like, the letter A on its own doesn't mean anything. It gets meaning from being part of a word, a sentence, a language.
Exactly. Context is everything. And think about how tricky that gets with our minds. We're swimming in symbols, but the system they're in is constantly shifting.
Yeah, not like a neat little formal system. More like we're making up the dictionary as we go along.
Based on every new thing we experience. That's why modeling human intelligence is so tough.
Because you can't just give a computer a fixed set of rules for meaning.
Our rules are constantly evolving. It's like trying to explain slang to someone who's never heard it before.
Right. The meaning's always changing, depending on who's saying it and how.
Precisely. And that brings us to one of Hofstadter's most mind-boggling ideas.
Get me with it.
The mind is a tangled hierarchy.
Tangled hierarchy. I'm not going to lie, that sounds kind of scary.
Think of it this way. Our minds, they're organized in layers, right?
Okay.
From the low-level stuff happening in our neurons up to our thoughts, ideas, all that.
So far, so good.
But these layers, they aren't neatly separated. They're constantly interacting, influencing each other in this incredibly complex way.
So more like a swirling vortex of ideas and perceptions all feeding back into each other.
A perfect image, and that's where the connection to strange loops comes full circle.
Okay, how so?
These tangled hierarchies, they create the perfect conditions for self-reference.
Right.
Systems that can reflect on and even modify themselves.
It's like those Escher drawings again. The hands drawing each other, which one came first?
Exactly. Creates this paradox, this blurring of levels that's both unsettling and fascinating.
And unsettling.
And Hofstadter, he argues this self-referential structure. It's at the heart of consciousness itself.
Whoa.
It's what lets us be aware of ourselves as thinking beings. Think about our own thoughts, question things, imagine those what-if worlds we talked about.
Okay, but if our minds are these tangled hierarchies, these self-referential loops, does that mean we can never truly understand them?
Ah, now you're getting it.
Are we forever stuck in a Gödelian loop, where our understanding of ourselves is always incomplete?
That's the fascinating paradox Hofstadter leaves us wrestling with. It seems like the very nature of consciousness, what makes us human. It's bound up with this inherent incompleteness, this inability to fully grasp our own minds.
So it's not like there's some missing key to understanding consciousness. It's that the lock itself, it's unpickable.
Exactly. But here's the beauty of Hofstadter's work. He doesn't offer easy answers. Instead, he invites us on this incredible journey.
A journey, okay.
To explore, to marvel at the strangeness of these formal systems, to see the creativity in Escher, hear those echoes of self-reference in Bach.
It's like he's saying, hey, this is mind-boggling, but it's also beautiful. Let's explore it together.
Precisely. And that's the spirit we need to bring to understanding consciousness. It's not about conquering the unknown. It's about embracing the mystery.
The wonder.
Yeah.
The endless possibilities of the human mind.
Beautifully put. And, this brings us to another key aspect of Hofstadter's work, his exploration of meaning itself.
Meaning? Go on.
He argues that meaning isn't something just out there waiting to be discovered. It's something we actively create.
We create meaning.
Through our interactions with the world. He uses a jukebox analogy to illustrate this.
A jukebox? Didn't we talk about that before?
Yes, but remember how we were talking about jukeboxes before, how they're so different from our minds?
Right. We don't have a fixed set of songs in our heads. And the world's not a jukebox dishing out pre-programmed meaning.
Exactly. We encounter new experiences, new ideas, new situations. And our minds, they have to make sense of it all. We have to create meaning out of the chaos.
So it's not like we have a mental dictionary where every word has one definition set in stone. It's more like we're constantly writing and rewriting our own dictionaries based on our experiences.
What a fantastic analogy. And this is where Hofstadter's ideas become really interesting. He argues meaning arises from the way our minds create isomorphisms.
Isomorphisms. Okay, now you've lost me. What in the world does that mean?
Well, think about how we understand metaphors. We take an idea from one domain, like the physical world, and we map it onto a different domain, like the abstract world of ideas.
Okay, I sort of get that.
For example, we might say, my mind is racing, even though our minds don't literally have legs to run on.
Right. We're borrowing from the idea of running to describe how our thoughts feel, using something familiar to understand something less familiar.
Exactly. We're taking the concept of racing from the physical world and applying it to the mental world. And Hofstadter argues our minds are constantly doing this, creating mappings, not just with language, but in all aspects of thinking.
So our minds are like giant metaphor machines.
Constantly churning out new ways to understand reality.
That's kind of beautiful. But if meaning is something we create, doesn't that make it subjective?
That's a great question. And Hofstadter, he grapples with that throughout Gödel, Escher, Bach. He doesn't shy away from the fact that meaning is subjective, but he also says there are constraints on how we create it. We can't just make up any interpretation.
Right.
It has to fit with our experiences, our knowledge, the structure of the world itself.
So it's like we're playing a game with rules, but the rules are always evolving, and we have freedom in how we interpret them.
A brilliant analogy.
Yeah.
And that's what makes studying meaning so fascinating. It's not about finding fixed definitions.
Right.
It's about understanding that dynamic process of how we make sense of the world, that creative process.
So it's not about the right answer. It's about asking the right questions.
And exploring the different ways we weave meaning together through our experiences.
This all ties back to Gödel, Escher, Bach again, doesn't it?
It does. All three of them, they were masters of playing with meaning.
Yeah.
Creating works that challenged our assumptions made us see the world in new ways.
So to really understand intelligence, we need to embrace that playful, multi-layered approach to meaning.
Go beyond those rigid systems. Explore those strange loops, the self-referential stuff that drives human understanding.
It's like our brains are doing a Gödel, Escher, Bach dance all the time.
Exactly. And that's what makes Gödel, Escher, Bach so groundbreaking. It's not just about the links between those three fields.
Right.
It's about intelligence itself, the beauty, the complexity, the mystery of how our minds make sense of the world.
And speaking of those strange loops and how meaning emerges from them,
Yes.
makes me think about artificial intelligence again.
Oh, interesting. How so?
Well, if meaning is something we're constantly creating and recreating in our minds, how do we even begin to build a machine that can do the same thing?
Now you're getting to the heart of it. That's one of the biggest challenges in AI, for sure.
If we're always writing and rewriting our own dictionaries, so to speak, how do we explain that to a computer?
Exactly. And this is where Hofstadter's ideas get really challenging for AI researchers. It's not just about faster processing, more data.
Right.
It's about understanding the fundamentals, creativity, meaning, consciousness, all of it.
So building AI isn't just about making machines that calculate better or store more stuff.
It's about cracking the code of what makes us human. And Hofstadter argues one of the key challenges is figuring out how to get AI to do something humans do so effortlessly. That subjunctive thinking we were talking about.
Right. The spherical football, imagining those what-if scenarios.
Precisely. That ability to imagine other worlds, to step outside strict logic and explore possibilities. Hofstadter suggests maybe that's essential for true intelligence.
Like a certain level of playfulness, being able to bend the rules in your mind.
Exactly. But it goes even deeper than that. That ability to imagine other realities, to think counterfactually, it's tied to self-awareness itself.
Okay, now I'm lost again. How does a spherical football make a machine more self-aware?
Think about it. When we imagine that football game, we're creating a world with different rules than ours. The players in that world would have to adapt, come up with new strategies.
So you're saying true intelligence needs the ability to adapt to the unexpected, to think outside the box.
Yes, but it's more than just problem solving. By imagining those alternate worlds, we become aware that our world, the one we take for granted, it's just one possibility among many.
It makes you realize things could be different.
Exactly. It helps us appreciate how contingent our own existence is, and that shapes our sense of self.
It's like our sense of me is defined by contrasting what is with what could be. Wild.
And this is where we come full circle back to Gödel's incompleteness theorem.
Okay, bring it home for us.
Gödel showed us, even in math, there are limits. There are truths out there that our logic systems can't grasp.
Right.
And Hofstadter seems to be suggesting that this inherent incompleteness, this inability to fully capture reality, it's actually a feature, not a bug.
A feature, not a bug.
It's what makes intelligence, creativity, self-awareness, all of it possible.
Hold on, so you're saying that not being able to fully understand ourselves actually makes us more interesting, more human?
Exactly. If we could reduce our minds to a set of rules and algorithms, wouldn't that make us less us?
It's like the mystery is part of the beauty.
The very fact that we can't fully understand ourselves, that's what makes us endlessly fascinating.
And maybe that's the takeaway for today.
Absolutely. Whether we're talking about human consciousness or trying to build artificial intelligence, it's not about finding all the answers.
It's about embracing the mystery.
The wonder, the endless possibilities of the mind.
And for everyone listening, think about that. What stands out to you from all this? What connections do you see in your own life? It's worth pondering.
Hofstadter leaves us with a lot of questions. Is intelligence more than just a complex system? Can we ever truly understand our own minds?
What do Gödel, Escher, and Bach ultimately tell us about creativity, meaning the universe itself?
These are questions worth asking, even if we never find definitive answers.
Because Gödel, Escher, Bach, it's not about giving us the answers. It's about making us ask better questions.
And that in itself is a beautiful thing. It really makes you realize,
The search for AI,
yeah,
it's not just about building machines that are faster or store more info.
it's about cracking the code of what makes us human.
Exactly. And Hofstadter, he says one of the big challenges in AI is, well, how do you create a system that can do this subjunctive thinking that humans do so easily?
Remember, the spherical football.
Yeah. That ability to picture other worlds, to play with what-if scenarios, to kind of step outside the rules of logic and just explore.
That's the key. And it's not just about playfulness either. This counterfactual thinking, those what ifs, they're deeply connected to our sense of self-awareness too.
Hold on, now I'm confused. How does picturing a spherical football make a machine more self-aware?
Think about it this way. When you imagine that football game, you're essentially creating a world with slightly different rules than our own.
Different rules, yeah.
And in that world, the players would have to adapt, right? Come up with new strategies, new techniques.
So it's like saying true intelligence needs to be able to adapt to unexpected stuff. Think outside the box.
Precisely. But it goes even deeper than just problem solving. By imagining these what-if worlds, we become aware that our own world, the one we take for granted, is just one possibility out of many.
Whoa. Like, things could be totally different.
Exactly. And that realization shapes our sense of self. It helps us appreciate how our own existence is. Well, it's contingent. Things could have turned out another way.
So our sense of me is kind of defined by contrasting what is with all the things that could be. That's trippy.
It is. And you know what? This brings us full circle to Gödel's incompleteness theorem.
All right, connect the dots for me.
Gödel showed us that even in the world of math, there are limits. There are truths out there, but our logical systems just can't grasp them.
Right, right.
And Hofstadter, he seems to be suggesting that this inherent incompleteness, this inability to fully capture reality, it's not a bad thing. It's actually what makes intelligence, creativity, self-awareness, all those things possible.
Wait, so you're saying that not being able to fully understand ourselves actually makes us more interesting, more human?
Precisely. If we could just break down our minds into a set of rules and algorithms, wouldn't that make us less us?
It's like the mystery is part of the beauty.
The very fact that we can't fully understand ourselves, that's what makes us endlessly fascinating.
And maybe that's the big takeaway here.
Absolutely. Whether we're talking about human consciousness or trying to build artificial intelligence, it's not about finding all the answers.
It's about embracing the mystery.
The wonder, the endless possibilities of the mind.
For everyone listening out there, think about that. What stands out to you from all this? What connections do you see in your own life? It's definitely something to chew on.
Hofstadter leaves us with a lot of big questions. Is intelligence more than just a complex system? Can we ever truly understand our own minds?
What do Gödel, Escher, and Bach ultimately tell us about creativity, meaning the universe itself?
These are questions worth asking, even if we never find all the answers.
Because Gödel, Escher, Bach, it's not about finding all the answers right. It's about making us ask better questions.
And that in itself is a pretty amazing thing.
You know, I'm still kind of stuck on that idea.
Which one?
That, our inability to totally get our own minds is somehow a good thing. It's like the mystery itself keeps things interesting.
Yeah, it's deep, isn't it?
Like if we could just figure it all out, solve consciousness, wouldn't that kind of ruin the fun?
Exactly. Some of the magic would be lost.
Our drive to create, to explore, all that comes from wanting to know who we are, right?
Right.
So, okay, back to AI for a second. If this subjunctive thinking is so important, have researchers made any progress there? Can you even program that kind of open-endedness?
That's a tough one of the biggest hurdles for sure.
Yeah.
Most AI now, it relies on these formal systems, good at logic, but not so good at saying, hey, what if the rules were different?
Right.
Hofstadter even jokes about a program trying to understand a story where the world runs on magic, not physics.
Yeah, their circuits would melt.
Right.
But isn't there that saying, like, any sufficiently advanced technology is indistinguishable from magic?
Yeah.
Maybe we're the ones running on magic. We just haven't figured out the spell book yet.
Now, there's a thought.
Right.
And it brings us back to those layers of meaning.
Yeah.
Maybe consciousness is a kind of magic that emerges from the sheer complexity, not some simple trick.
So earlier we were talking about how meaning isn't just out there waiting to be found. It's something we make. Does that mean we're all just making stuff up? Is there any shared reality at all?
That's the big question, isn't it?
Right.
The eternal debate. Hofstadter argues that, sure, our interpretations, they're personal, but they're not just random. They're grounded in our experiences and logic.
Okay.
He uses that word isomorphism.
Right.
This idea that our minds make maps between different areas of knowledge.
Like how we understand metaphors.
Exactly. We take something concrete like time and say, it flies, even though it doesn't literally have wings.
We map the physical world onto abstract ideas.
Right. And those mappings, they're how we build a model of the world.
So even though my model of the world might be different different from yours.
Yeah.
We're both working with the same basic reality.
Otherwise, we couldn't even talk to each other.
Right. It's like we're all playing different instruments but riffing on the same song.
That's a great way to put it. There's this underlying harmony to it all.
A shared structure.
And it connects back to Gödel, Escher, and Bach.
Of course it does.
They were all playing with systems of meaning, showing how complexity can come from simple rules.
And how even within those rules, there's room for creativity.
Like Gödel proving there are things that are true, but you can't prove them within the system.
Yeah, it's like he blew the roof off of what's possible.
Exactly. And Escher did that visually with those impossible spaces, making us question what we think is real.
And Bach, with his fugues and canons, all those intricate musical structures looping back on themselves.
On layers.
It's like he was composing strange loops before Hofstadter even came up with the name.
Right.
It's amazing how Gödel, Escher, Bach ties together all these different things. Math, art, music, even AI. What an incredible book.
It really is. It shows the power of thinking across disciplines, you know?
Yeah.
Seeing connections instead of just separation. And for anyone listening out there, that's the challenge.
What do you mean?
Don't box yourself in. Look at those eternal golden braids in your own life.
Those surprising connections that make things more interesting.
Exactly. And as we wrap up our deep dive into Gödel, Escher, Bach...
Yeah, it's been a wild ride.
It really has. I'm left with this sense of awe and wonder.
Me too.
But also a ton of questions.
Like, is intelligence more than just a system? Will we ever really understand our own minds?
What do Gödel, Escher, and Bach tell us about creativity, meaning the universe itself?
These are questions worth thinking about.
For sure.
So for everyone listening, what stands out to you? What connections do you see now that maybe you didn't before?
Because Gödel, Escher, Bach, it's not about giving us all the answers.
It's about helping us ask better questions.
And that's a great place to leave it.
Thanks for joining us on this deep dive.
Thanks for having me. It's been a blast.